Hi, good morning. I'm Tom, and I'm going to talk to you about turbulence and tidal turbines. But the real question here is really energy, and where does our energy come from? At present, most of our energy comes from fossil fuels, but there's a number of factors here, such as climate change and the security of their supply, that's leading to an increased demand for renewable energy. Within the UK, the majority of our renewable energy currently comes from offshore wind. But we have the largest resource of tidal energy in Europe, and we're not using it. The tides are driven by the gravitational pull of the sun and the moon, and they're therefore predictable, flowing in and out twice a day. This is a real advantage when we compare to wind energy, which is dependent upon the weather. But what's turbulence got to do with this? Well, turbulence describes the chaotic motion of a fluid, and it's all around us. Every time we breathe, the air flowing into and out of our lungs is turbulent. I'm sure we've all experienced turbulence on an aircraft, and all the way up to the largest meteorological scales of turbulence, which is why the weather forecast isn't always right. And tidal flows are no exception. They're very turbulent. So it's important we understand how these chaotic, turbulent flows interact with a turbine so we can ensure their designs are going to survive the harsh operating conditions and is an economically viable source of energy. So my research has been conducted through a number of experiments and CFD computer simulations, and this research has shown that as the turbulence increases and the flow becomes more chaotic, the forces acting on the turbine increase, and they increase by up to 20%. So if turbulence isn't accounted for in the design of the turbine, it could lead to problems such as blade failure, which has been one of the problems with a number of initial demonstrator devices to date. My research has also shown, though, that for a farm of multiple turbines, the power generated actually increases. So this is a good thing. The next stage to take my research from here is to use this information and collaborate with material scientists to develop new materials capable of withstanding these harsh conditions. And the ultimate aim of this project is to reduce the cost of tidal energy. So thank you very much for listening. Thank you.